This is going to be lesson 2-6. This is trigonometric chain rules. And trigonometric stands for trigonometry, saying it nice and slow so you know I can pronounce it. We are on standard F still. We've been on standard F since the first lesson. What is that standard again? Look at your notes. What is F?
It's F.
Standard F. What does it stand for? Come on, girls.
I'm checking.
Not chain rules. Because standard G is also chain rules. Then
How's basic derivatives?
basic derivatives. There it is.
Why does F stand for basic?
Because standard F, we're just going through A, B, C, D, E, F. Next one is going to be G, and it's going to be advanced derivatives. Yeah. All right, so we have the setup down. Here is the knockdown of the notes. So the first thing that I want to do is take the derivative of sine. So derivative of, I always have an A out in front to let you know that there will be maybe a number or something in front of this. Always remember to rewrite that same A. So I'm rewriting the same A. And now I'm going to take the derivative. The derivative of sine is cosine. Notice here, I'm going to rewrite the same U, the same inner, and I'm going to even write that on the side. Always keep the same inner. And maybe you want to write U here, but you're always going to have the same inner every time. And then you need to multiply that by whatever U prime is. Oops, I want to change that back to blue. Come back. And maybe I should color code this because, no, I'm just going to keep it all blue. So this is going to be times U prime, whatever the derivative of the inner. Remember, we have daughter, dinner. So I just wrote daughter. The derivative of the outer, sine, is cosine. And then you always have to remember dinner.
So it's always going to be cosine for sine?
Always going to be cosine for sine. Yep, that's the rule. And this is going to be really confusing, especially when we start going backwards with derivatives. We are going to go backwards with derivatives. They're called antiderivatives or integrals. But the sign in front of this is going to be a little bit confusing because, and I'll show you this guy, the derivative of cosine is negative a sine of U.
Why is it negative?
Yeah, why is it negative? Oh, that's actually a really good question. And it takes me too long to answer it for us to still have time to work on the worksheets. But if you want to, I can come to you after class or some other time, but it's a good question.
Do we need to know?
You don't need to know. It's a good to know because then you have a better conceptual understanding of what the heck is going on here. And I can even prove it to you. I don't know if that's gonna. Okay, whatever. So yes, S. S is a good way to remember that it stays the same. So S is for same, and maybe you want to underline this S, the same sign.
Wait, can I ask a question?
Go for it.
Well, it's not really related to this exactly.
Can you wait until later?
Yeah.
Okay, sounds
Wait,
good.
What does the same sign mean?
So notice how the sign over here, a sine of U, had a positive sign. And when I took the derivative, it's also a positive sign.
But then cos didn't, and it turned negative.
Exactly. Cosine, when I take the derivative of cosine, it's a negative. So it's not the same sign. There's no S for same sign.
Whenever there's sine, it stays the same.
Whenever there's a sign, it stays the same. That's the little mnemonic that you can use.
So it's just a better way to memorize it?
Yes, exactly. Same sign.
Always keep the same inner, no matter what.
The same inner, yes. Same U. And then you have to multiply by dinner.
Okay.
Or D inner.
Dinner.
And
Dinner.
so this is going to help us when we get to antiderivatives. But remember that this S for same sign, this applies when you're going forward, when you're taking the derivative. You're not going backwards and taking the antiderivative. So try to keep that in your mind. We'll come back to it, so I will remind you.
Is anti with that weird squiggly line?
Yeah, this is antiderivative. Like this. I can draw it better, and I'll get better practice once I write it over and over again. All right, and finally, tangent. Tangent is a weird one. So it's just one that you're going to have to commit to memory. Here we go. Derivative of A tan U. We always rewrite that A. Don't forget to rewrite whatever it's being multiplied by. And it's going to be secant squared. Secant squared of the same inner, U, times, what am I going to multiply this by, guys?
U prime.
U prime. Derivative inner. And what do we call U prime? Our little dinner, yeah. Our little cutesy thing. Dinner. All right. So I want to make a note here on the side that secant squared of the inner, this is really equal to secant of the inner, all of that squared. It's just another way of writing square. So this is the trigonometric way of writing a function squared. So it's really saying a times the secant of u and then square that secant of u. Alright. So
Is that that's a U?
yes.
Okay, I get it.
Alright, so I want to write a few examples and we can finish our notes. So I'm going to go to the next slide. Is everyone done writing?
Yeah.
Alright, cool. Next slide, here we go. I'm going to do red for examples. So, examples. All right, numero uno. We have the derivative of 2 sine of 3x. Okay, that's going to turn into what? And you guys can do it. You have the rule in front of you.
So then it's gonna be 2 cos
2 cosine
3x
of 3x
times 3.
times 3 for the simplified answer of
6 cos of 3x.
6 cosine of 3x. And can we pronounce it in this class cosine? I know you write it down cos, but can you verbally say cosine?
No,
It just irks me. I'm sorry. It's just one of those things. I'm not going to take points off. I'm just going to be annoyed. Cosine.
So you're gonna hate us.
No, I'm going to be annoyed. I'll still love you guys.
You're sometimes are a little sassy.
I get it from Carly.
Last year you were very sassy.
I was always sassy because you were sassy to me first, Carly. I just dish it back.
That's how she is, though. That's just like Carly.
Gotta get used to it.
You learned that with me.
All right, number 2. Let's take the derivative. The derivative of, I'm going to put parentheses around here so you know what I'm talking about. Parentheses, negative cosine, not negative cos, negative cosine of negative x. And then I'm going to end my giant parentheses here. All right. So Sophia and Kaylin handled our last one. Kaylin simplified. Sophia took the derivative. You guys, I still want you to take the derivative, Sophia and Kaylin, but I'm going to give someone else a chance to tell me what it is.
Wouldn't it be positive?
Positive cosine
Positive
Yeah.
sign.
or positive sine?
Positive sign.
Positive sine,
Times minus x.
sine of negative x,
I mean of negative x.
okay,
Times minus 1.
times negative 1. Okay, so I need to point out what happened to make sure we all understand and make sure the people watching the video understand. We had a negative cosine, but we know that a derivative of a cosine is a negative sign, so the double negative came in to make it a positive sign. But because the inner was negative 1, dinner was negative 1, my final answer becomes someone else.
Negative.
Negative
Oh, sorry.
sign. It's fine because we let someone else take the derivative. That's the most important part. Simplifying is one of the easier things. So negative sign of negative x. Can we all say that together like a kindergarten class? I want you guys to say negative sign of negative x on 3. Ready? 1, 2, 3. Negative sign of negative x. Of negative x, right? Okay.
Said that.
Okay. You said it really quiet like you were confused. Is it of or is it times?
My voice is really bad, Mr. Smith.
All right. And the final example before the summary. I'm going to actually add some notes on the side, so it's the final example, but not the end of our notes. The derivative, I want to take the derivative of, I'm gonna challenge us. Let's see if we can get this. I'm going to say 4 tangent of natural log of x. Oh boy, here we go.
Yummy.
All right. This is anyone's game. I'll take anyone.
Not like
4 secant squared.
I hear Sophia says 4 secant squared. Oh, that was a badass. Let's try to write that again. 4.
That's what I'm like, thanks.
My handwriting needs improvement. 4 secant squared of what? I can't hear.
ln of x.
How do I pronounce ln of x?
Natural log
Natural log of x. Okay.
times
natural log. I'm kidding. 1.
1.
Times 1.
yeah.
Okay, so what is our inner? Is our inner x or is it natural log of x?
Oh, wait, it's like natural log over x.
Something like that. Yeah. Do you remember the rule for taking derivative of natural logs?
Or would it just be 1 over ln?
Not exactly. It's not 1 over ln.
Would it
ln over x.
No.
4
ln over negative x.
over 2?
1 over x.
It's 1 over x. Yeah. We'll add that note again. So this is a review. D dx of 4 natural log of 3x is equal to 4 divided by whatever was in the parentheses, 3x times dinner. What's dinner?
Delicious. Just kidding. 3.
Times 3. We are so funny in here, so witty. Yeah, so it's you keep whatever's on the outside of the natural log, and then you divide it by whatever was on the inner. There's no ln, there's no natural log when I take the derivative, unless I somehow.
You also have to multiply by 3.
And you have to multiply by 3 because that's multiplying by
What?
We just did dinner.
dinner, exactly.
Oh. Yeah.
All right, so
Where did you get the 1 over x from?
that's a good question. So the question, I'll repeat it again because I don't think everyone was listening. Carly. So the question was, where did that 1 over x come from? Why is it divided by x? And someone else answer that.
Is it
A is 1 and the inner is x.
Inner is x.
So you put the coefficient over the inner.
so natural log equals 1?
So
There's
Joy is
no
saying
in front
that
of it.
it's like 1 times the natural log
It was like 2
of x, like that.
Okay. So then
Cool.
would you have to simplify that?
You could simplify this one step further just by writing all of this divided by x, but I'm not going to because that's kind of a dumb simplification. If you want to write it, you can, but you're basically as simplified as you can get here. You just have to divide all of this by x. All right, so maybe since we've been simplifying, I'm going to go ahead and do it. Whatever. For, man, I cannot write my s's correctly today. For secant squared of natural log of x, all of this divided by x.
Wait, I thought you said you weren't gonna do that.
I feel like I just need to be consistent, although I did it with a different color. Okay,
I can't say.
the one thing I just want to make sure we remember, never forget. Never forget
Never.
that Mr. Sandell is the best teacher ever. So never forget, no, the dinner.
Never forget the dinner.
I will never forget.
I will never ever forget.
Because otherwise you're going to go hungry, right?
Yeah, Kara says that she eats like once a week. At
I believe,
dinner.
I believe
Maybe exclamation mark. All right, go ahead and write your summaries. If you're watching the video, thanks for watching. Say goodbye, girls.